Welcome guys. In this video I'm gonna find the value of a limit and we're gonna prove that value L is the actual limit of the function that we're given at that specific value. So let's find the limit first. So we're given that the limit of x as x approaches 2 of 3x plus 2 has to equal a number. So let's see. The way we do this one is we plug in 2 for here. So that would be 3, 2 plus 2. That is 3 times 2 is 6 plus 2 equals 8. So L equals 8. That's the first step. So write the first step. Now we're gonna do some scratch work to find to before we do the proof. So we know in the proof has two requirements. We need an epsilon and we need a delta. So let's choose 2 epsilon. Let epsilon be equal to 0.01. That's the second step. So the third step, we're gonna relate the epsilon with the delta. So how do we do that? We start with this quantity. We're gonna take this one. We're gonna do 3x plus 2 minus the limit. The limit is 8. So we're gonna do minus 8 has to be less than epsilon. Remember, epsilon is 0.01, but right now let's just leave it like that. So this quantity is equal to, we're gonna make it look differently, so that way I'll show you why we're gonna make it look different. So 3x plus 2, that's gonna be 3x plus 2 minus 8, that will be minus 6, and that is equal to, we take out a 3, so we're gonna do x minus 2. Okay, that is looking more like your delta, because remember, your delta has to be looking like this: x minus the 2, that's your c value, that's your c, has to be less than delta. So whenever delta is less, whenever x minus 2 is less than delta, then the function this is your f of x. Your f of x minus the limit is less than epsilon, so that completes the proof. So first, looking at this, it looks like this. So what, remember, this is less than epsilon. So what if we let delta be equal to epsilon over 3, because if we divide by 3, we're left with x minus 2. That's what we have here. So let delta be epsilon over 3. Okay, and remember, epsilon is equal to 0.01, so we let 0.1 over 3. That is gonna be equal to 0.0033, and that is repeating decimal. So now we did the scratch work. That's the third step. Now the fourth step is to write the final proof. So to prove that this is the limit, all we have to do is this. We have to say f of x, which is 3x plus 2, f of x minus L is less than epsilon whenever x minus 2 is less than delta. So now let's plug in what we know. Okay, so 3x minus 2 minus 8, which is the limit, is less than 0.01. So that's your epsilon. It's less than 0 whenever x minus 2, remember 2 is your c, whenever it's less than your delta, which is what we find here, 0.0033. That completes the proof. So the first step is to find L. You're given a function, you find L. The second step, you have to specify your epsilon. Now you do some scratch work. You try to associate your this quantity f of x minus L with your delta quantity. So once you have that, you find your delta, and then the last step is to write the sentence, and that's all you have to do for this type of problem. Whenever you have to prove that something is a limit using an epsilon delta proof. Thank you very much. Please don't forget to subscribe to my videos.